overlay designs. I just want to talk about overlay designs briefly. I'm not going to spend too much time on these, but so what we have in overlay designs is we have an existing pavement. You have we need to estimate the condition of the existing pavement. So we take the surface out, a little bit from the surface out, but the damaged pavement, if you're putting an overlay on it, structural analysis, the same structural analysis is done. You need to do it, and you need to estimate some kind of a damaged modulus of the existing pavement. So damaged and undamaged modulus of the existing pavement are input in the overlay designs for level 1. For the level 2, distress surveys are used to estimate the damage level, and level 3, windshield surveys are used to estimate the damage in the field. So the way that in the rehabilitation design, so they look at some kind of a damaged master curve. Undamaged master curve is estimated, and then damaged master curve is estimated by in level 1 based on FWD testing. Falling weight is deflectometer. So you look at let's say an estimated frequency temperature combination at FWD test. Let's say you get an E star of this. Let's say estimated undamaged modulus is this, so you come up with some kind of a damage ratio. And that damage ratio is used in calculating the E star master curve alpha parameter based on the damage. And then from that, we come up with also another issue is we use field cores to estimate the mixture volumetrics, like air voids, asphalt volume gradation, viscosity parameters to define AVTS values for the existing pavement. So we also use we use predictive equations for the undamaged master curve based on this. What was the original dynamic modulus master curve at the beginning of this construction, this particular existing payments X number of years ago? That's based on all this. This is another method to come up with an indirect result modulus tests, but I'm not going to get in there. And essentially, we look at that damaged master curve equipment. The Mepdg use a damaged master curve. These are, I'm showing different levels. And here, level 3 use typical estimates of mixture models based on prediction. So based on like a very rough estimate of whether excellent, good, or fair, or poor, the damage is estimated from this visual survey. And that damage is also used, that damage parameter value is used to estimate an damaged master curve alpha parameter. If you remember, this alpha parameter in the tornado plot was one of the most significant parameters. So that is a very significant input to dynamic modulus. So they use this damaged E star to calculate the dynamic modulus master curve of the existing pavement. And the new overlay placed on the top, you put whatever you measure in the lab, and that's how the analysis proceed. And the rest of the predictions are pretty much the same for the layer. It's an overlay, yeah.
Did you design that as a new pavement going forward, though, taking the old master curve, putting the overlay on top of it?
Yeah, so you use the old master curve for the existing damaged master curve is the existing pavement. It's cracked, whatever. You put the overlay, let's say 2, 3, 4 inch, and when you run the pavement mean analysis, it runs the structural analysis, finds the stresses and strains and all that, and runs the fatigue. Use the fatigue formulations to calculate the distresses over time, and that's how you've determined the overlay thickness. Okay, importance of construction quality. So all these pavement designs and all these things are extremely important, but this is the slide that we discussed yesterday that I want to show again. So segregation is a big issue that we need to be worried about. Whether it's thermal segregation or gearbox related segregation, These are some issues that we discussed yesterday, but takeaway from you is construction quality control is extremely important. And that's how I want to start both of these sessions. So I finished a bit 15 minutes early. So we can do a Q&A session, discussion session, or just leave. So it's